we can use the Qr factorization to solve least square approximation problems. Remember that the least square approximation problem is when you try to minimize some vector r, which is defined by AC minus B. Okay, you want that length to be minimal, okay, because there is no true solution to this problem, but you want to find the most accurate solution. Now remember that the Qr factorization is when you decompose a matrix into two matrices Q and R. And so if we substitute that, we get here QR times C minus B. Okay, now we can factor out the Q. And here we can write Q transpose B. Why? Because Q is orthogonal. So Q transpose, or Q it's the same thing, and that should be equal to the identity matrix. Okay, and now we know also that an orthogonal matrix doesn't change the length. Okay, if you apply some orthogonal matrix to a vector x, the length remains the same. Okay, so this is equal to RC minus Q transpose B. Okay, now we can define D to be equal, let's maybe rewrite that, we can define D to be equal to Q transpose B, and we can also define it to be equal to the vector composed of D0 and D1. We'll see why we do that. We will see that soon. Okay. So why do we do that? Because if we do our Qr factorization, we get our upper triangle matrix, and there are maybe rows that only have zeros. Okay, and remember here, basically, we can rewrite our equation to be equal, to the following. This is equal to we can rewrite the right side as so let's just first rewrite RC minus D. Now we can rewrite that as R0 C minus D0 plus D1. Okay, because as I said, our upper triangular matrix R contains maybe rows that have only zeros. Okay, and they don't really help us. And so basically, your vector D will be will have the same number of rows than your upper triangle matrix R. Okay. So let's say you have 4 rows, and the 2 last are zeros. Okay, then you have something here. Your vector D has the same number of rows. Here, your vector D doesn't necessarily have to also have rows with only zeros. Okay. But as I said, these rows, they don't really help us, so we will cut them. We will remove them basically. And so your matrix R0, it's R, but only with the rows where there are non-zero elements. Okay, and you will also cut by D. Okay, so you will only take the same number of rows as by R. Okay, so and that will be defined by D0. Okay, and so D1 will be the other rows, will be this here, and that will be here. Okay, so this D1 here, these are the rows that we can't use because the same rows in R have only 0 elements. Okay, and so now you can solve the Qr factorization. Once you've done your Qr factorization, you find D equals to Q transpose B, as we defined it, remember? And then you find R0, so you take only the non-zero rows of your matrix R, and then you also take the same number of rows in D. That will be D0. Okay. Okay. And then to find the solution of the least square problem, you will solve R0C equals D0. Okay, so C are the unknowns, the values you are searching. Okay, and so that will be the solution to your least square problem. Okay. Yeah. So thanks for watching.